Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 424. Minimize the maximum adjacent element difference. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, if you look at the video length, the live solve portion is about like almost 3 hours, maybe a little bit less actually. But with this explanation, this is going to be a very long video. I'm recording this now, so I don't know how long it is, but it's probably like 3 hours long, and you're like, well, this is a hard problem, which I agree. But that said, it's hard saying that and then say that I knew how to do this immediately, but I just couldn't put the pieces together. I think the hard part about this particular problem for me is that it ended up being a little bit of case analysis, but I think the tough part for me is that the case analysis, I was not able, or it took me a long time to be convinced and proved that it was sufficient, right? Because basically, with case analysis, you have to prove that you handled every case, basically, right? Or you could prove by AC, I suppose, and I didn't do that very well. But that was the thing that I was missing for this particular part. But once, I don't know. I stopped in 2.5 hours. I don't know. I don't think that's a great solve, but I'm just going to explain to you how I did it. You could, of course, watch me solve it live. But it's like I said, it's kind of weird for me to say that, like, oh, I knew how to do it immediately, and then didn't do it immediately. It took me a long time, mostly because I was just playing around with different ideas and different concepts as well. Okay, so let's kind of break down a few things first. Let me actually bring up my drawing board real quick. Right? Oops, what is going on? Tell me why. Okay. Right. So there are a couple of first observations, right? So let's go over the problem a little bit first, which is that you have this idea that, okay, so you have some negative ones, right? And here I assume that you understand the problem, because I feel like sometimes people leave comments and they're like, I don't understand the problem. I'm like, well, at least understand what they're asking first. But in any case, you can choose. So you have a lot of negative ones in a sequence, and each of them can be two numbers that you've chose in the beginning that you get to choose, and you have to minimize this difference, right, between adjacent elements. So okay. So the first thing I would say, and these are a number of cases, right, is that if you have, for example, if you have negative ones in the beginning and for symmetry proof at the end, but let's do the beginning first, is that if you have like negative 1, negative 1, negative 1, negative 1, and then 5, right? Well, the thing is that all these can be basically compressed into negative 1, 5, and the reason is just because, well, you would never, like, so you get into two numbers, you can choose X and Y. You can choose either X or you could choose either Y, it doesn't really matter, but you will always only choose one number, right? Because why would you choose two numbers and increase the difference, right? So that's basically the first thing I would say and notice. And in a similar, or without loss of generality, the exact same way really is that you could do it at the end as well, right? So if you have 5, negative 1, negative 1, negative 1, negative 1, you compress the end as well, right? So then you have 5, negative 1, right? Without changing the answer. Okay, so that we established that. Okay, and then now there are really just two cases. Ooh, how did that happen? Hang on. There are two main cases, right? Is that okay? So then now we so we have a sequence. I don't know, whatever, right? That's terrible, but I don't know. I'm just writing random stuff. We already took care of the beginning. We already took care of the end. That means we have to take care of stuff in the middle, right? So the stuff in the middle, why I kind of phrase it this way is that, well, that means that you have negative ones delimited by real numbers, right? Or numbers in the integer range, but just, I don't know why I said real numbers, but just like numbers that are not placeholders, right? So you have something like this, say. Whatever, let's just leave it that way. Change color real quick. But yeah, and then here, the first thing to note is that, well, if you have more than, if you have two or more, I don't know why my drawing thing is like really funky today. I don't know. If you have two or more things, well, you can compress them down to just two things, right? And the reason is because you have x, y. Yeah, you have two numbers, so you can't choose a third number anyway. And so because you have two numbers, then you can only choose two numbers, right? So yeah, you can maybe choose this to be x, this can be y, the other way around, or xx or something like this. If you want a concrete example, let's say you have 1, -1, -1, 100, then your answer could be 133, 66, 100, or something like that, right? And that could be a possible answer. The other possible answer, of course, is like 150, 50, 100, right? And of course, in this case, it may be that, like, you know, you had earlier on, like, I don't know, if you have like 50, 50, -1 or something like this, right? I think that's actually wrong, but I don't know. But you can make a case such that you want the inner numbers to be 50, just to kind of yeah, because you need the second number later on, right? So maybe if you have like a million, actually, maybe that's a good example as well. Like you have a million, -1, -1, 1 million. I'm going to just write M for mil. Then here the second number would be 1 million, and you know, you won't waste the second number here. So then you have 1 million, right? So okay, so these are very, so, but to bring it back here, these are the two cases. So you given that you have compressed them down to two numbers, you could either have two numbers or one number, right? But you know, and then the other case is that the other case, of course, is just the simple, you know, one number thing, right? 1, -1, and it can be, you know, a number like 5 or something. It doesn't, you know. Okay. So yeah, so that's kind of establishing order cases, and I did kind of immediately, or maybe like within the first 2 minutes, say I really had this idea where I okay, so and oh yeah, one more I think, I mean, maybe you see it, but I just want to make it explicit, is that let's say you have a chain of things, it really only matters of adjacent ones, right? Because we only look at adjacent elements. The 4, or rather, the 6 here will never interact with this 5. So you only have to kind of break it down to, okay, well, we have this thing, and then we have this thing, right, to handle. And the way that I think about it is with actually binary search. Honestly, I never thought it could be anything other than binary search, because the numbers are so big. The numbers, and I'm looking at the screen, but I'm not really highlighting it, is that the numbers are in the range from 1 to 10 to the 9th, which is really big, and then you have a minimum possible difference between adjacent things. So there are really only two solutions, or two possible ways that I thought about it. One is with binary search, the other is with greedy. Like if there's a solution, right? I didn't know. I mean, I think that it really narrows that down for me. Is there's either some greedy or some analytical situation or solution, something like that along those lines. But for me, the only one that really made sense was binary search, in terms of if I could be able to solve it. I mean, if I was able to solve it, then that's the thing that I'm able to do, right? Like, I'm not going to invent a new thing out, like a new formula to solve this. So I don't know. Yeah, and then from that, the idea I had was that, okay, so looking at these cases, and maybe I can just erase this, is that now, well, initially I was trying to think about how to greedily choose this, right? It's like, okay, so we do a binary search. What does that mean? Binary search, we're saying that, okay, the minimum of the, so that means that the maximum number, the maximum differences between adjacent elements is going to be some number k, say, right? So that means that, well, we'll replace this with either x or y, but let's just say a for now, right? Then 6 minus a, or absolute value of that. I guess I don't have to write it out. we can just do absolute value of this is less than or equal to some number k, and then we just kind of like, you know, dot it out, right? Okay, so what does that mean? So for me, but you know, if you look at this formula 6 minus a, it can really be a number of things, right? It can, you know, another way to write this is is that you have 6 minus a is less than or equal to k, or a minus 6 is less than or equal to k, and then you kind of just do the math, right? With the a, put a on the other side, and yeah, because you know what k is, because we binary searching for it, so you're trying to figure out a, then now you have 6 minus k is less than or equal to a, which is, you know, you kind of just keep on writing it out. Yeah, or k minus 6 is less than or equal to k, a, right? Which you can kind of put an absolute value back in, right? So that's really the idea. And of course, if you kind of think of it this way, it is just, you know, the number a, what is the range that it could be if, I mean, I did all this thing, but maybe another easier way, just in case you want to think of it another way, is that, okay, well, we have 6, right? I mean, that's like the math part, but if you have the number 6, the next number has to be within k, so really it's just 6 plus k or 6 minus k, right? So you have this range of numbers, right? That it could be possibility, and then so forth. Well, I say so forth, but yeah. But the way that I thought about it, and maybe some of this is influenced by Q2 and Q3 with the intervals, is that now I'm just dealing with this interval, right? Like we don't have to choose a number, we can just keep track of an interval. And then now we can revisit the cases that we have, right? Okay, so let's do a very simple example, right? Is that we have, change the colors actually. Yeah, so let's say we have 1, I don't know, yeah. 1, -1, 100, right? Well, and let's say for now we're searching k is equal to 20. Well, in this case, actually, well, it's just not possible, right? Because why? Because here, from the one side, it is saying that the next number can be, well, 1 plus 20, which is 21, or 1 minus 20, which is -19, which we can probably just adjust to 0, but either way, that's the interval, like that's the constraint that the left side puts to the right side. But then now, the 100 also puts a constraint, and the constraint is that it has to be 80 to 120, right? Something like that. And you can see that these two constraints, well, there's no answer, right? There's no possible answer, so we're already saying that k cannot be a possible answer. So that's part of the binary search. But of course, you can also play around with, like, say k is equal to, say, 60, right? Then, well, one of the the 1 can be from, I don't know, I'll just write 0 because I'm too lazy to do the math, 0 to 60 range, and then the 100 can go from 40 to 160, right? And then now, what is the overlap here? Because that would determine what this number can be. And the overlap is just determining that this number can be 40 to 60, right? So that's just the intersection of these intervals is 40 to 60. Hopefully this makes sense so far, right? Because, and you can also kind of check your math in a very simple way, which is that if you look at number 40, let's say you put in number 40, the delta here is going to be 40, the delta here is going to be 60, which is less than or equal to 60. And then, of course, if you fill it in 60, then, yeah, then the delta left is going to be 40, or the delta left is going to be 59, and delta right is going to be 40, which is also going to be good enough, right? And you can also play with like 61 or something, just to, you know, get something outside the range. Then, actually, maybe I messed up on this one. Maybe I'm off by 1 and something, that's why. But let's say you have like 65, right? Something clearly outside the range, 65. Then it's 64 to the left, which is too big, right? So no bueno. Okay, so that's basically an exhaustive look on this one case. The one case being if you have, let's just call it A -1B, right? So if you have this case, then we just have to do the math on this section. I mean, we kind of already did the math, but you can also do it again. I mean, we'll go over it in code, but yeah. And then another case, right? is not this one. It's the harder one, which took me a long time to figure out all the nuances. And I don't even know, maybe technically it's not even right. I just proved by AC, right? But yeah, but like I said, there are two cases, right? Two main cases that we can think about. But honestly, they're kind of the same one if you kind of generalize it. The thing is that, okay, well, this number, there's one very straightforward constraint, which is that it has to go from a minus k to a plus k, right? And the same thing from this one, or similar from the other direction, is that b minus k and b plus k. And let's say, without loss of generality, because you can flip it, let's say that a is less than b, right? Just to keep our cases a bit smaller. But I do want to rewrite this because this is just terrible handwriting, like even bad even for me, right? So okay. But then the question is, okay, right? Basically there are two things you have to do for this one, which I didn't really think about. The thing is that, okay, well, look, because a is less than or a is less than b, well, we don't have to care about a minus k because because a minus k is going to be too far away from b no matter what, right? I guess technically b could be exactly a and it doesn't, but for the most part, you don't have to consider it, right? Because you want to just, you want to just see if these two things overlap, right? The thing is that, okay, if they overlap, which actually means they can only overlap if a plus k is greater than b minus k, right? Because as we say, remember, a is less than or greater than b, so you can kind of draw it out where, you have a minus k, b minus k, sorry, whoops, I put a plus k, sorry. And then the second line could be either here, then you have b minus k, b plus k, which is no intersection, or if you have b minus k, b plus k, then there is an intersection, right? So that means that, this formula kind of is rather than is an intersection. And the reason why this matters, and maybe there are other ways to do it. I think I see code that doesn't handle this explicitly, but I did anyway. So if there is no intersection, then that means that it requires two numbers, right? And really, that's pretty much it. So then here, I just marked down that, okay, we need two adjacent numbers, not just two numbers, but maybe you can think about it as like two adjacent numbers, right, are needed for if it's equal to k. That's all I do it. Otherwise, I just kind of put this set of constraints in, right? I mean, they could overlap, they could not overlap. It's fine, right? Because it goes up to the formula. And then, okay, so now let's say we have all these constraints of all these. I mean, I think about these as constraints, but they're intervals, right? But you have to satisfy all of them with two variables right? And so how you do that, right? So basically, the way that I think about it again is like I would say for the Q2 and 3, which is with intervals, right? So you have some. So now you have intervals of like, okay, some. Okay, let's do the number line first. Let me clear this out. Right. So let's say you have a number line, right? So let's say you have a number line. You have basically this is the requirement. These are the requirements, right? That's what these intersections are for, or these segments are for. Sorry, right? And then now the idea here is that, okay, you're trying to find two numbers that will give you the answer. The way that I did it is with sliding windows, even though it took me a while. Or actually technically it's sweep line. Sorry. Sweep line, not sliding window. My fault. It's too late in the day. But yeah, you try to do it with sweep line, right? So you're given a line you're sweeping, and you're going from left to right, and you just basically try to find two intersections. And the first one is actually pretty. There are a couple of ways you can do this actually, but there's an additional constraint which I'll talk about later. But basically, as you sweep from left to right, well, what happens? Well, when you encounter the first, when you encounter the first, endpoint exit, or the first end of the segment. So here you would actually have 3 segments. So when you encounter the first exit, that you have to choose this point in a greedy way, right? The reason why you have to is because if you move a little bit to the left, and I'll choose another color for it. If you move a little bit, to the right, then now this thing is not included. So you have to include this interval, and as a result, you have to choose the first thing that it enters, right? So that's one of your point, right? So that's point 1. I don't know why I wrote 0. I was gonna write down 1, but right. And then now and of course here, the way that I did it is a little bit awkward, but it also means that because it's satisfied here, and obviously it overlaps here, so that means it's satisfied here. So we can kind of ignore the endpoints here for now because it doesn't matter that they get called, right? And then now, what I do, right, is that so there are a couple of ways you can check for this, but the way to get the second endpoint, it turns out, is just to get the endpoint in which every interval is in, right? Or every other interval left, right? So for example, if you have this case, then here, the first point, this is the first point in which all the remaining intervals are still in, right? That's how I think about it anyway. And the reason why and you can actually do the same logic as before and choose the first place to after this. So in this case, this is the way that I drew this is pretty whatever. But yeah, like I also choose this point as a valid point. But the reason why and the reason why you can choose any points in between is because, well, all these points are overlap, right? So because all these points are overlap, you can, in theory, choose any of these points. But the reason why I chose greedily choose the first one is because if there's a case in which we have, like, I don't know, like what we talked about before, if there's a case that requires 2 straight numbers, like something like this, for example, then now you want this line to be as close as this line as possible, right? To keep the min the same while corresponding to all the constraints, and because of that, then you want to just make it as small as possible. And that's it. That's really I know that there are a lot of special cases as we talked about, or it feels like it, and I've talked about, like, for 20 minutes about these cases, but that's the idea. I mean, it took me 20 minutes just to explain it, so that's why it took me 2 hours. But those are just coming up different cases. But we'll go over the code right now. And I will admit this is not the cleanest code, or not even clean code. But but I hope the idea is enough, and you'll play around. Okay, so here I just get the max delta. So the max delta is the biggest existing delta between 2 numbers, and this is just actually a case that I did forget to as I talk out. But for example, if you have it doesn't matter what all the negative ones are, but you have like 1, 1000, -1, -1. In theory, you could choose these to be 1s and these to be 1000s, but it doesn't matter because 1 and 1000 is going to be the smallest difference, right? So that is basically what this max delta does. It looks at adjacent elements, and if they're both not -1, we just choose the delta. And here, if there are no negative ones in the number, then we don't have a choice anyway, so we just remove max delta. Okay, and then we'll just skip to the binary search real quick, because binary search is binary search. Well, that number is going to be the smallest number that you can choose, so that's going to be in the range, right? Because you don't have to search for anything smaller because it's not possible, right? And then the right side is going to be max of the numbers. You could probably choose a better bang, honestly, but the reason why it is max is that if you have, well, it's just like a very huge upper bound, right? Because if you choose all the negative ones to be 0, this would be your answer, for example, just because, yeah. I mean, you could probably do the math that way. You could do the math and see why that is, right? And then, of course, underneath that is going to be, think my neighbor is being loud. But yeah, underneath that is going to be just a regular, straightforward binary search, right? Again, I'm not going to go over it in this video. I think we talked about it in the binary search in the daily video like a couple of days ago. So definitely check that out. But yeah. And everything else is just this mess, honestly. Oh, I forgot to talk about the pre-processing. So here, this is so before the binary search actually is the compression, right? So this is just putting the what I call the -1 compression, and it is kind of what it sounds like, but it just basically puts in a data format that allows me to kind of basically go number of -1s. And then you have a number, and then number of -1s, and these could be 0, of course, just to be clear. Number and then ... So that's basically the way that I format these. Yeah. Actually, I don't know what the start n is for. Maybe I took. Oh no, n is here, but I don't know what the start is for. Maybe I took it out. But yeah, and it's just basically trying to compress the array to this number. To this format. I start streak is equal to 0. I found is equal to false, because the reason why I have this found thing is just because of the beginning and the end, right? Basically, what we talked about is that if and it's kind of very awkward, honestly, the way that I wrote that, but it's just the thing that I was saying, right? So if you have -1, -1, -1, -1, 5, then you can compress all these into just one -1. So that's kind of inside this code, even though it's very ugly with this found and streak thing. And then streak, we put it before every number. In a negative, I put. I don't know if I am a fan of this format, but I just call it a negative, right? And the idea here is just that you compress it down to 2. So if it's bigger than 2, you set it to 2, and if this number is bigger than 1, you set it to bigger than 1 on the end, and also to the beginning. And that's really it. I just compress it. There were ways to do this. I read some code after that, but this is the way that I did it. Okay. So then now we already talked about a binary search, but we have this good function where the mid is satisfied. So yeah, so I'll put it here. So whether whether there is a solution for k, right? So that's basically it. And I think about these as intervals. We could think about it as intervals or constraints. Constraints, right? Here, yeah, this is just for the first number. So the first number, if it is not 0, then yeah, you just do this thing, right? And I don't know that I talked about it specifically, but I think yeah, I think the math is very easy. But we have like -1, -1, which we compress, so we compress it down, and 10, right? Then the first number has to be basically 10 plus k or 10 minus k, right? Pretty straightforward. You only walk one, and there's no additional constraint, so we just kind of add this constraint, right? Otherwise, we have this repeated as we go to false, and that's just my way of handling whether for this k we are forced to have 2 adjacent numbers or 2 adjacent -1s to be different numbers, right? Yeah, I mean, we'll talk about this when it gets up more. But as you can see, I go from the first index, I go for every 2 numbers. And then now, if, yeah, and there's really only 2 cases, right? I don't know why I have a container here. I guess it's just container. If we have either one question, one openness below, or 2, right? So this just means if we have, I don't know, like we already talked about this a little bit, if we only have one -1 in between, then yeah, then we just do the math for the intersection of what could be in the middle given the k that we can have, right? Yeah, so you have this as the constraint from the left side, this as a constraint on the right side, and you don't intersect that, so that's all you have. And of course, technically I plus 2 could be out of bounds, so the next thing is the last number, and if that's the case, then you just kind of, you know, this is yeah, this is the case where you have stuff at the end, so you have like 5, -1, -1, but you compress them, so it's 5, -1, and so forth, right? So that's the case you have here, right? And this case is if you have some number, you know, 1, -1, -1, and then Oh no, you only have, yeah, this is this case, right? Where you do have a number underneath. So yeah, and then you just do the math this way. We already talked about the math a little bit with the intersection. I mean, all this math is just this stuff, but with the intersection calculated. And yeah, if there's no intersection, then it's false because it just cannot be happen. Otherwise, you put the intersection as one of the constraints. And this is the tricky part that took me a long time to figure out, because I actually spent, like, I think I got most of this written about like an hour in, so it wasn't even that fast, but it took me about an hour to kind of get most of it, but it took me an additional hour and a half to kind of get the rest, because I just kind of was stopping on this part and repeated as part of this. But yeah, so this is the first -1, this is the second -1 in the let's say 1 -1 -1 100 case, right? So you have the left side, you have the right side, and then you have the constraints here, you have the constraints here. So then now there are two things, right? We already put in the constraints, so that's fine. But yeah, so here, if we're forced to have two numbers, I just said repeat is equal to true, and we'll handle it later, right? If we're forced to have two numbers used, right? Otherwise, if otherwise if it's 0 on the I+1, it just means that we don't have a -1. That means this means that we have two adjacent numbers with no -1s. And you can actually even do like I mean, I kind of did this way because we already did this thing. But now that I think about it, if you get rid of this thing, you can actually put something like you know, you could have also maybe done like if absolute value of right, I+2 is less than, or if greater than k, then we return false or something like this. And we have to check that I+2 is in bound and stuff like that, but you could have done it that way as well. But yeah, but otherwise it's 0, so there's no constraints, so we don't have to care about it. So okay, I kind of did this in a sloppy way, as I said. So these are the constraints, right? And then next I convert it to a you know, like a difference thing from left to right, so that I could do a sweep line. I probably could have done this from here from the start, but honestly, I think this is for me anyway, it's not a meaningful optimization, and it allows me to think about it in a more abstract way, because now I could just think about these as intervals, and I don't have to worry about like off by ones and stuff like this. So, but anyway, but yeah, it deals with three things, which is the x component, the type, which is the beginning or the end of an interval, and then just the index to keep track of. And I kind of did the rest of this in a very, very ugly way, honestly. But it just basically goes over the solution that we talked about, which is that I think I could. Let me rewrite this a little bit. Yeah. Yeah, this is just a mess, honestly. But this basically implements what we talked about, right? And what we talked about is that, yeah, so my idea here was that I was trying to go through all the cases, and I missed a bit, so it gave me a lot of wrong answers. But this is terrible code, just a lot of if statements. Is that, okay, well, you go until you see the first exit, and the first exit is just like the t is equal to -1, which is here. So if count is equal to 0, then what I did was I copied everything to first, and we just kind of have a new array, and everything in first is going to be whatever, and then we here, as in like we don't like their constraints are satisfied, right? So yeah, so these constraints are satisfied, so we are good, right? Otherwise we just do a first here. Yeah, and here we're just trying to because this is the first place we terminate, right? And else we assert, so this is actually always going to be true, or should be true. But yeah, but this is basically the last endpoint that contains this index, right? And what I mean by this index is that because we don't choose this point, index will not be in another thing. So it's what we talked about in the sweep line, right? So yeah, so this is the index. And then now if this is 1, then it just has to be the first thing that we see, right? If which actually we have it here. which is that I increment count so that now we are on the second the second thing that we're picking, right? And if it's equal to 1, then yeah, last is equal to s is the first thing that we've seen. But we keep on updating until right? Until now, yeah, because we want the beginning of it, so then now the next time you do exit, and here there are two ways to exit, right? So here we ignore the things that we've always ignore the things that we've seen. Maybe they're not. I'm gonna rewrite this slightly. So yeah, so maybe we have a scene or like yeah, just done, right? And then here first is no, it's gonna be currently is done, and then maybe current set, right? So then now you could think about this. Then now, okay, well, if count is equal to 0, and we see a new thing, then it's gonna be current, right? And then now you always want to see current, update current. But then now if it's 0, if it is in current, and it has to be in current really, then now you make a copy. Maybe these variable names are slightly better. Yeah, but then done is going to be a copy because these are all done, right? And then now if index isn't done, we just continue because we already finished it as the first part. Otherwise, we make sure that it is in the second part, which is the current part. And yeah, and then we increment the count, which means that the last thing that we added is going to be s. And then this just makes sure that we, you know, if it takes more than 3 segments to in this greedy way to account for, then we just return false, right? Like we need 3 segments to intersect all these things. Here, I just have an additional constraint, or just double checking that if you know, if there are 2 numbers in a row, then we just make sure that yeah, we just make sure that that the constraints can be met, right? And that's basically, if we have 2 numbers in a row, then we know what the 2 numbers is, right? Which is confusingly named last and first s. So then we just have to make sure that there is equal to k. And last can be none because in the case where you only have 1 number and it intersects everything, right? But yeah, so that's really the idea here. And that's pretty much it. It's very, I don't know, it's very piecemeal, it's very case analysis, but that is what I have. I'm making it small so you can kind of see more of it. But you can see that this is 130 lines. But yeah, I'm going to show you the code real quick. But that's all I have for this one. Let me know what you think. And yeah, this is going to be O of n, right? This is also O of n. Yeah, and I'm going to go to the binary search. I mean, this is going to be O of m, where m is the max number. And of course, the max number could be 10 to the 9. So this could be, and log of that is going to be 30, right? So yeah. Yeah, and then now the good function, right? This is O of 1, this is O of n, just going through all the pieces. And this is n log n, because for each n, or each -1, it can have an event, but the only could be n -1. So this is, I mean, and you know, it's not specific, but it's just going to be n log n. And here, right? Yeah, that's pretty much it. And this is O of n, right? Just push things in different places, in different sets. And yeah, that's pretty much it. That's all I have for this one. And yeah, don't forget this. Thanks for watching. And yeah, you can watch me struggle through this next. Okay, so that feels good. Let's give it a YOLO. Hopefully they didn't make a silly mistake. Okay, that's good. Okay, Q4, only 65 people got it, so we're in for a long night, it seems like, possibly. I mean, it's a little bit cheating because I probably should not know this if I was doing a real contest, but I can't force myself to not look at this. Maybe I should write like a script to remove it, but for virtual contest, but it is what it is. Okay, so let's read. Minimize the maximum adjacent element difference. Values and nums are missing. You choose a pair of xy exactly once and replace each missing element with x and y. What does exactly once mean? This is such a poor problem. I see. Okay. Actually, no. It's not a pair for each -1. It's one set of numbers, and then we could choose that to be 1, 2. Okay. Nums is either that or 10 to the 9, so that's pretty big. Okay. I mean, this is a pretty big number. Minimize the maximum. So I'm just getting my iced tea while thinking. Or herbal tea, really. My first intuition is going to be binary search. In binary search, is everything forced? Would they give 2 binary search problems in a row? Well, the thing is that strings of -1s don't matter because you just have the same number, so the difference is always 0. So you can actually compress all the -1s together. That's the first observation. So it only matters if they're in between numbers, right? And the two, okay. The thing with binary search is that you can go 2 directions. You can go up or down. And this is not, oh, number. That still feels like that's going to be it, the binary search. It's just a very tricky binary search, probably. Maybe. I don't think there's a DP. Maybe there is, I don't know. No, that doesn't make sense. I don't know, it still feels like a binary search. And keeping track of the possibilities. So then now we have a range of, so okay, so we want to do a binary search. For every -1, we could do a range of numbers. Can we? So then now here you can say if it's 4, then maybe it's -2 to 6, even though it has to be positive. So maybe 0 to 6. I mean, that's an easy thing, right? And then now going to 10, you have to kind of merge the intervals. So then now you have, and really that's it, right? You only have to consider 2 modalities. And then now if the 2 numbers distinct, maybe. This is honestly where I usually go to the leaderboard and kind of see how many people have gotten it. But Leetcode messed up the virtual leaderboard as well. So it's so you can't even do that anymore. Even the people who solved it in so long. This is too cheating for me. Okay, I just stopped doing that. But yeah, I feel like a range thing makes sense. Because then it's just do, and then you merge all the things, right? And then now you merge all the int. Okay, let's say we have a collection of intervals then, right? That we think it could be possible. How do we decide whether there are two numbers that satisfy? I mean, I guess you don't have to choose the two. It is how would I do that? Okay, I think that's the hard part for me for now. So you have, let's say you have three intervals. How can you choose two numbers out? How do you choose whether it exists that the two numbers in between, if they kind of overlap in some weird way? I guess the thing with number line is that there's no cycles. 5, 2 to 6 to 8, and now this one would give me 2 to 5, but then how do you do it? Is that a DP then? Is it greedy? Well, you probably want to sort them. What happens if you sort them? Then that means that all the intervals so you have to find two numbers inside all the intervals such that it intersects, or that it is almost like a set covering for k is equal to 2. Is there a solution for k for 2 set covering? Can I sweep? And even one number is fine, that's true. But how do I choose between something like this? I guess we'll do greedy. What would that greedy look like? Basically the last endpoint of one of the interval. Okay, so you look at the last endpoint of the first interval that ends because and then you remove all the things and then you do it again, maybe? I don't know if that's right, but I don't know that I have another way, so let's okay. I mean this is not easy though, so we will see. There's always an answer because you can just set them to something, right? So that's if you choose them all to be 0 anyway, so okay. Right. I don't know if this is right at all. Okay, so if this is good, we want to try something smaller. Alright, pretty easy, right? How many point was this? Oh. What am I doing? Now. My computer is very much lagging. Alright, whatever. I just wanted to see what the point YU is. I guess it's here somewhere, right? No? Probably not. 8 pointer. Alright. What I want to do is compress the negative ones because the negative ones don't matter. Wait, no, they do. You cannot compress the negative ones. Oh no, this is going to be so annoying. Even if this is right, I don't know if this is right anymore, but because the case may be that you have something like -1, negative, or like 5, -1, -1, maybe just 0 or 1, whatever, 100, and then now you can't compress the negative ones and just convert them to 50. What you would do is convert them to, I don't know, 25 or whatever, maybe not even, but the point is still taken, that then now the answer is 25, not 100. Okay, so then now you have to figure out where can things be, right? Is there a non-binary search greedy way? Okay, so let's say there's no -1. I guess if there's no... Okay, so everything in the beginning and the end can be compressed though, because then you just set it to the first number. Oh wait, no, you might not want to set it to the first number. I mean, you can. I forgot the XY thing actually, because I was doing it backwards. Because you can only choose to be 2 numbers, right? So you always choose it to be one of the number. So it doesn't really matter. So compressing it, you want to at worst compress it to 2 numbers, or 2 -1s, because it can only be 2 numbers anyway. Right? Because then now you choose the 2 numbers, whatever it is. Okay. But then, you know, that's the rest of it. Right? Is it binary search? It's not an easy binary search, that's for sure. I was thinking about it in terms of intervals, but I don't know that this is right anymore. It really doesn't feel like an easy way to do it. I mean, not that this is an easy way to do it, but intervals just has a lot of math that I don't know that I know. Is there another way to do it? Let's say we have a target. If it's 1, then it can also be 9, 10, 9, 8. This is kind of a weird one, but okay. Okay, let's say we have X and Y. Well, let's say we have X. Can we figure out Y? The minimal Y? I mean, we could with binary search, but then now we have X. Right? Is X always one of the numbers? Maybe that would be a good start. No, because this is 9. But is it always... If we only a couple of cases, maybe. There's either one of the numbers in between the numbers, because by definition that would be the choking point, maybe. And if we have one of the numbers, then we can figure it out. So maybe we can have something like that. So okay, so we have double. Then now we can... I don't know, what are other cases? Like -1, -1, I don't know, 1, -1, 100, I don't know. Would you even... that's such a hard problem. It's such an annoying hard problem. So probably you want the first number to be the first number and the last non-negative one number. You want to test that. Do a binary search on those. That's fine. Well, it cannot be always one of the numbers, and it cannot be. You cannot test every number in between because then you have way too many numbers. Do you choose the one with the biggest gap? If you can, I don't even know if that's true, because let's say you have something like this, right? And then now you have, like if you choose 50, this is going to get cooked. I guess it's going to get cooked anyway, but I don't know that I know any way of doing this one, honestly. I feel like binary search is a great idea, but how much time do I have left? An hour? This is definitely feels like one of those problems that I really don't know. Sometimes I at least have some ideas. I guess the interval is an idea, but I don't even know how to kind of get into coding that. I don't know. Honestly, no idea. Like given a thing, I don't know how to come up with the XY. Right? Like given a 1, what would you do? I guess in this case you can work for it, but every -1 is different, right? Or like the same, rather. Even though these examples are kind of terrible in illustrating what they want you to do, in terms of just understanding, but man, I could never go home or go sleep early with these contests anymore. I don't know. And that was 5 minutes. I just did nothing. I'm not fresh enough for this either. Do I always want to? Like, is this... Okay, so let's say I have this case. Do I want... So if this is 50, then this is going to be... some, you know, 50, I mean, it's going to be dominated by this. But if I choose this to be 10,000, then... That is a better... No, because it's this would be bigger. I don't know. So is it the one with the biggest gap? Well, in this case, you could choose 2 of them, right? So it's the 2 numbers with the biggest gap. How would you choose the 2 numbers with the biggest gap? The reason is because, almost like in a weird pigeonhole thing, right? Because if it's not pigeonhole, then or I could choose one and binary search the other. Does that work? Maybe. I don't know. I feel like I have some ideas, but honestly, I don't have any good, even like reasonable proofs to enough for me to kind of try it. I feel like the biggest gap, if there was only one number, the biggest gap kind of makes sense, because then that would divide the biggest gap in half, and that's the best you can do. But what if there are 2 numbers, right? Do you really choose the big 2? And how can you, like, what is the minimum in that case, right? And of course, then you have this case where you just take 2 numbers, but that's fine. That could be spun out really easily. Yeah, and really, a lot of these numbers don't really have states, so it should be fine. Let's I don't know. let's try it. Why not? I don't know. And let's just put it in we want to say nums and then there's like some weird thing about rounding, but yeah, okay, so that's a candidate. This divided by 2, right? And then the gap is just also this is wrong. This should be the gap divided by 2, right? So this is just a gap. Oh, but then you also need the numbers, so how can I just say, I don't know if this is right. So then now we take the 2 of the biggest gap, right? Did I not print anything? Okay, this doesn't really come up. Oh, this only comes up once. If it's 1, then the gap is 8. You have 2 and 10, and this should be an absolute value apparently, which is fine. Okay, then it's just about choosing 2 of these, right? I think the odd even thing is a little bit odd, but that's fine. I wonder if there's like a weird case. Where like, okay, let's say for the 3 case, right? So you have 1, -1, -1, 100. So we want this to be 33, say, right? If it's bigger, then this will be closer. So this, let's say, I have 1, so then now we have 1033. So then now this number will no longer be. So we convert this in a greedy way to just so maybe, well, then this would not be the biggest gap, right? So by definition that can work. So in order for this to be a gap to be considered, there will have to be less than 100 away. So that means that this is like 900 or something like this. And then so then in order for this to be then now this is 1033, which means that the biggest number now will be And also technically true, but you can imagine that you have 1 or 2 in the beginning, and then just -1, and then you go all the way around 100 at a time, and then at that point it'll be 10, 2, or something like this, right? And that will just be the same. Pretending that we fill in the rest, because then now this number is ginormous. But can that really be? Can that really be fixed? Maybe not. I don't think that there's a way to work this. Spent 15 minutes not doing that much, honestly. Alright. Can we do this with bounds? Alright, I mean, my first idea was in the rows. I just don't know that I know how to do it. Honestly, I don't really have an idea. I'm just kind of trying to see. Okay. Oh, why would they let you click on this? This is just silly. Can you actually click? Oh, no, don't show me. But why would they do that? That's a little bit weird. How people are so fast on Q3? I guess I was just slow today on 1, 2, 3. Oh, look. Alright, let's pre-process this. So then now we can do by. Oh, because of this thing. Alright. So then now you have the positive numbers. Do we care? No. Okay. So there are only 2 cases, because anything more than 2 is... And we don't care about... Do we care about the front stuff? I guess we kind of do, but... of G. If this is greater, or if it's 2 elements, then just might as well be 2. Right, so okay, so okay, so then now we have that. And then maybe just how do I think about this? Cases where you have 2 numbers maybe, and then or two variables. Yeah, I don't know how to do this, honestly. Like, okay. Okay, so we look at the numbers and then we interval them, right? I don't have the concentration for this, honestly. Okay, so let's say how do we look at each number and then go to do it? I have 93 people got it. That's not bad. 40 minutes left. I see. So if there are 2 numbers, then it's always going to be, if there are 2 uncertainties, then the bounds are pretty much set anyway. Okay, so then now, how do I do this? I don't know if this is right, but okay, so there are really 2 cases, right? So you have a number, maybe I don't use XY because that's the input. Then the number is going to be, if you have 1 number in between, then it's going to be the range A plus K for some target. Maybe A minus K, A to K. And then intersection of this with B minus K, B plus K, something like that, right? And if you have 2 question marks, 2 negative ones, then it is not an intersection. It's just a choice. How do that's a possibility, right? What would that even look like? do you merge the two numbers? I guess you don't have to. It just has to be in that range. And then you do a scan. Right, I don't know. How do you do the prefix? So, okay, what does the prefix look like? You have a one number back, and you have two numbers back. Is it 2 times k? I guess it doesn't have to be. No, why would you change it? It's the same number. So okay, so for the prefix you would compress it down to 1. Right, same thing with suffix, and then everything else, and then it's just about sliding window or sweep, maybe. Right. Okay, so then now what would that look like? That's just, I don't know why I should try to do a group by. Okay, so then now for so maybe we'll say found is equal to false. Okay, so if num sub I is less than 0, or if, okay, if this is a number, then that's fine, right? Else if this is a number, that's fine, and then found is equal to true. Else is a -1. If we are found, then maybe streak is equal to right? Else streak is always just going to be equal to 1 because we haven't found it yet. Then when we found a number, we want to put in all the streaks, maybe. Okay, so then for numbers, so you do the previous streak. Something like this, but I'm doing it weird. Okay. And then else, and then at the very end. And right at the very end, maybe we have yeah. Okay, maybe that's a little bit, I don't know if that's good. I don't know what I'm doing. Okay, so then now we have 1, 2, 2 should have, oh no, 2 is fine. The 10 should have a streak of 1, and 8 is 0. Okay. And maybe that's fine. 0 and 1. The 1 is weird. No, this is not max, this is min. Okay, so nothing in the beginning, nothing at the end. I don't like my data structure, honestly. But, yeah, so then now we have 1 number in between. And 2 numbers in between. Right? These are all the cases we have to handle, that's all. Yeah. How do you think this should be? Maybe that's slightly better, I don't know. And we are good with that then. And then we also want to I think now we have what we want, maybe. I don't know. I'm not going to finish this on time, am I? Okay. Okay, and then now the target, right? So now we have some intervals, right? So now, okay. Okay, so then now we start at the number 1, actually, and then here we start with if is greater than 0, so only if, oh, well, it'll never be greater than 0, but if this is not 0, then it's -1. That means that it is a thing. Then now we want to insert append array of 1 minus k or minus target. Let's just call it k. And then array of 1 plus k, right? And then now, yeah, okay, so then now if yeah, okay. If array of I plus 1 is equal to -1, then we have only one number, so then you just append also I minus k, I plus k. Oh no, the intersection of this and so the intersection of this and this, right? What is the intersection of those two? So that is going to be max of this, min of this, right? Okay, then now else if, oh, then it could be 0, I suppose, else. Okay, so then now if it's 2, then we want both of them. I don't know why I got it in. That's actually a bad typo. Okay, and then now we have all these intervals, and we want to we have all these intervals, right? Yeah, let's take a look at those intervals before I go on. How much time do I have left? 25 minutes, 26 minutes. Yeah. So we try okay, so we try 5. That means that we have the numbers can be between 5 and 7. Is that right? I guess so, because 5 from this and 5 from that. Okay, so I feel like I'm happy with this idea. Now we just have to figure out if this is solvable, right? So, okay. Okay, yeah. So then now interval starts sort. You got this, Larry. It's just events, right? I probably did this a little bit funky though. Yeah, maybe I'll optimize it in a little bit, but for now, we'll just do this. Yeah. Something like this, right? And else if it's -1, then now count is 0, we increment, and then sin is equal to basically we want to ignore future use of this, so maybe we just do Yeah, okay, maybe. Does that work? Is there an extent? Nope. How do you make a copy of it? Dot copy? Does that work? I hope so. Okay. Okay, so if index is in C, otherwise we just ignore because it's just that it is in first. We can assert that index is in first maybe. Else, so count is equal to 1, then you should be done, right? Yeah. Else, if index not in first and index not in scene, return false, maybe. Something like this. I don't know if this is right. I think the idea may be right, but assert index in first. It's okay, so try to 2. Why is that? Okay, so these are the events. 8. So you try 2. Oh, this is weird, isn't it? Eight, 4 is not a very weird interval. So that means this is wrong, right? So, okay. Something like that. Maybe it's off by 1. What is the answer anyway? 401? Huh. I mean, I don't believe this at all, but I am going to YOLO submit because I don't have time to think of a test case or be exhaustive about test cases. I don't think it's right, yeah. I mean, it's very easy. Oh. Oh. Well, this is just a silly case, but okay. So, okay, how would that look? Okay, if -1 not in nums, then for x, y, and z. Okay. Well, I don't think it's going to be right, but oh, why is that wrong? Oh, wait, I thought I have, oh no, I thought I put some in, but then I guess I didn't. Okay, well, this is a silly one. I thought I have a thing in for this. 41i plus 2, okay. Oh, So basically, if it's the last number, okay, I mean, why would that not? Oh, I guess I just didn't have a case for it. Okay, fine. If I plus 2 is to n, or length of array, really. Okay. Otherwise, then this is just the n, so then we can actually this is just the n, so then we just append the standard. Okay, maybe. Okay, that seems right. So let's give a submit. Okay, I mean, so this is just -1. Expected 21. Am I misunderstanding this? Why would you not choose 1313? Oh, Larry, this is the same mistake. Okay, fine. Max delta is equal to max whatever 0. Technically it's min delta. Okay, then we just baked it into this thing. Oh, that's not great. Oh, this is just sloppy. If x is and y is okay. Okay, very silly mistake on that one actually. How do I keep on doing? This is 11. Oh no, I thought I had a case for this one. Did I not test it? -1, -1, 100. Oh, I guess this one I just eat. No, this one should be. Wait, why is that 11 and not 14, 14? Am I misunderstanding this problem? How much time do I have left? Maybe I can upside. 13 minutes is kind of cutting it close. I don't know that I understand this problem then. Expected 11? Huh. What is that? Am I misunderstanding this problem? Oh, I see. No, I'm dumb. And also this should not have been 0. You replace it with 1, 1, and then it'll be whatever. So why would this be? Because then it is. Okay, so something's wrong. Can I solve this in 13 minutes? I don't know. Okay, I get it. What? I misunderstood some part of how I try to solve this. Well, just I mean, the code should have corrected me. Okay, so 29. Oh, this has to be. Well, I need to fix this to be positive. I don't know that matters actually, but still. Okay. But we choose it to be 0 at 14. Oh yeah, we could choose it to be 14 and 46. Why is this not right? Why is this 11? 14, 25, 37, 25, 36. Can't even do math. But why? Oh, because if you choose 14, no, of course, okay, yeah. If you choose 14 and 46, then you have, okay, yeah, you're dumb, Larry. Because then you have this thing. Because, okay, so how would I... Okay, I misunderstood some part of this, I think. Or like how I want to handle it. So I just kind of got the intersection of those forced intervals. In that, okay, so what will my intervals look like for 0? If 14 to 14, 46 to 46. And that's just not good enough. Because the intervals that I care about, maybe this was never going to work, I don't know. And we have 2 steps, which is fine. But then you have to connect the tissues. So that means that, how do I connect the tissues? So this is the, it's not this part, it's this part. So you have these 2 things and you have to connect them. And the thing is that the delta here, I have to do the math on this. I guess I just got a little bit lazy on kind of closing. Okay. Okay. Focus. Okay, so you have 1, -1, -1, 100. If you try to do 0, it would... That's not... this math is wrong. Because then now... we actually want... Okay, so you have this, but you have an additional constraint. You have is it just an additional constraint? Of this intersecting with this. Oh, okay, so maybe we could do this thing that we have. Ooh, what happened? So you have, but then now you have two Ks. And then something like this, maybe. I don't know. It feels right. Oh, well, it feels like a reasonable path. I don't know if it feels right. I mean, it does not look right enough. Well, I mean, the answer's not right, so. Okay, 11 gives me 2 to 25 for the first one. 3 to 57. Is that right? So you have 11 to 2 to 25, okay. 46, okay. And then 24 to 36. Is that right? I mean, this is good, but... Okay, so that means that you have 14. If you choose K, you have to... That's not quite right, though, because you want 14, 25, 36, 46. So that math is definitely not right. 24 to 36 is an intersection. So okay. So I need something. This extends too much. So we want it to be okay. So you want the difference between how do I handle this? Or at least can I figure out in 7 minutes? I mean, we could probably figure out eventually, but okay. So this is not quite the way to handle it. So 11 would go twice, give you 25 to... I think the thing is that I need this to be a one-step situation, as someone said. like a one intersection thing. It has to be part of it. It cannot be in its own independent thing. But this part intersects with this part, which is why it's a little bit awkward. And this is, well, no, this is true because it's just true, right? But I don't know why the 8 is right. 8 is right because this minus 16 is 30, this plus 16 is 40. But, oh, wait, no, this is just wrong. This should have been forced all along. Defense. Okay, so this is 1, this is 2. This should have been the third, right? So count is equal to 2, right? Oh, I have to do if no, you see a new number. Oh, no, it's not an and, it's an or. That's why. No, that's not quite right either. Okay, so then the index for the index for this one. So these are the events. The index for this one is 2. That's not right. Oh no, that one is right. But index of 1. So it for count of 2, then index of 1 is not seen. So why is this not? Should be done. Oh, because of this, I'm just being dumb. Okay, so if count is less than equal to 1, then you have this, then else return false. Okay, that's actually not a great mistake, but also a fixable mistake, so that's fine, maybe. Where's my print statements? I have so many print statements. Or maybe just this one, actually. YOLO. How much time do I have left? 5 minutes. Oh well. Oh well, okay. So I have 3. Line 61, which is not great. Let's just print our array. -3. Oh, I thought because I set it as max. I'm dumb. Oh no, that's fine. But streak is equal to max streak of 2 because that's the only thing that we care about. And still no bueno. Oh well, too many silly mistakes. -2, -3. Oh wait, I meant min. Okay, I apparently cannot do stuff like this. Programming is hard for Larry. Alright, I don't even know if it's right, but or like I don't know if the previous numbers are right. Alright, well, this is looking bleak. We have 3 minutes left, but we're gonna keep up solving it, I think. Okay, so this is that's okay. Yeah, well, I don't know, I feel like I'm close. I don't know that I am or not, honestly. These problems, it's a little bit on the greedy side, and greedy is always a little bit tough. -1, -2, 159, -1. They think that the answer is 73, but expected is 49. So actually, my answer being higher is actually not expected for me anyway. Okay. So that means that 73 should definitely be a 72 should be a true. And you have all these things. Right, what is this again? You have -2. I really, the way that I handle the extra case, I'm not super happy about, so I wouldn't be surprised if that's probably why. But yeah, we add. Oh, maybe there's some like sorting thing, because of how I do this. But because the second time we close, I think I double count the second time we close. Okay. No, that shouldn't matter. I didn't skip it. I thought I would, but okay. So it can't go to 1. Then now, if index is in first, we skip. I think that's really it. Did I get 49? Yeah, okay. I don't. 49 seconds left. I'm just going to YOLO submit even with the print statement, so I might print a little bit too much. But yeah, okay, it gives me a wrong answer anyway. So, but I didn't really have time to take it out, and maybe I did, but I don't know. All right, let's see what silly mistakes am I making on this one. So -2, right? Supposedly, right? My output is better than the output, which is actually worse than the other case, because the other case is, I can think about it, but okay, 87. I still don't know if this idea is right, or is that an edge case. So okay, so I mean it thinks that 100 is right. So it thinks that 98 is good, which is actually should not be. Okay, so did I handle this correctly? Maybe my states are a little bit terrible. Okay, so it's in first. We continue if index is in scene. Okay, assert index is in scene. And then it should be here, right? So I don't know. Does that change anything? No? Okay. Okay, so we didn't solve it during the contest. I'm going to debug this part. Okay, so why is 98? So we have this streak. Is this a thing where the zeros are coming to bite me? I don't think so, actually. So the first is going to be 112. Alright, let's just print that out. Okay. Okay, so we have a 98. So first is 113, second is 250, and then it returns true. Okay, let's take a look at the scan. So these are the events. $113. So then now 17 index 2 is going to be the first one, maybe. Yeah. Well, 2 or 0. So then 250 is next. But then we have a 412 after that, right? But this is fine in theory. Am I? Maybe I just don't know how to handle the two cases very well. Okay. Because then you have this. Let's put it on screen. I was going to write on my notebook, but I mean, the timing doesn't really matter anymore. Okay, so then if we have 100, we want 313, 213, 113 maybe, I don't know. 53, and then 113, 113, 1 or 14 is fine, right? But how do I think 87 works? Okay, reason why, because it thinks that 102 to 228. 102 to 28, right? So then it thinks that the first one's 213, 228, 102, 53. I mean 102 minus 14. 102, 102, 14, right? What is that? 102 minus 14 is 88. I mean, this is 87, which means that it's kind of wrong anyway. Wait, I would, oh no, I returned 87. So 87 isn't even right, but 2 minus 102. Oh, 228 minus 102 is very big. I don't know how to handle this case, I think, where you have... okay, I kind of hacked this together and but it is clearly not right. Right? Okay. I really have to figure out how to handle that. Basically, you want the intersection to exist. Right? And that's what this thing is. Yeah. But do I have to does this have to exist? I don't know, that would make sense. But that only makes the answer even better. So it would not solve what I want to solve, right? So that doesn't really make sense. How does 87 though? Yeah, I don't know how this gets 116. Okay, let's take a look. Okay, so if we draw the intervals, we would... Actually, let's also just print. Why does it never get print missed? Oh, I missed it. So this never gets print, so how would this ever be forced? Oh, it probably is forced earlier. I guess I do have other things that determine it, but okay, that's kind of weird actually, but okay, so then now you have these intervals that copy and paste it up. Alright, so okay, so I have 87, these are my intervals that I care about, say, and then these are the things, right? So then now the first thing to be -1 is going to be at 102, okay, and then that gets rid of 315 constraints, so 315, but then the 2 is new, and then the 0, and the 2, so it'll be 228, right? Which is fine. So okay, so you have 228, 102, but how do I do the math in this? That means that my constraints are wrong, right? Because basically it's saying that, okay, 313, right? That means that yeah, I mean my constraints are just wrong, because I'm trying to say that it's 313 minus k, and then it's 53 plus k, and then now, so 313 minus k minus 53 plus k has to be less than or equal to k, right? Yeah, okay, so then now if I mean it's a little bit awkward because there's an absolute value here, which is why I'm struggling a little bit, But okay, but yeah, so maybe this is a slightly better format than just me being a little bit lazy on the plus minus k. But so then it's just plus minus k over 2 though, right? So this is k over 2 maybe. Yeah, I mean, I might have a a rounding error, but you know, that's just, I mean, that'll be a good welcoming problem. I mean, this is just wrong on so many of these now. And of course now we actually get, you know, the thing. Is it just off by 1 though? Can it be? I don't know. It doesn't seem like it could be just off by 1. So maybe we need both this. Wait, was it right before? Other than for this case? I guess I might as well check now that the contest is over. Actually, all the numbers kind of match except for the 100. But you have this 228 102 thing. And I don't know how to do it. Necessarily. Okay, so then now minus, okay, let's just do the math. Maybe I messed up the math. Okay, so wait, well, this is plus k and this is minus k, so I think I just messed up anyway. So it's going to be this no. This is minus 2 times k, right? So then now you times or add k on both sides, and you have 313 minus 50d, or plus k on both sides, or plus 2k on both sides. So you have this. Does that even make sense? Honestly, I don't know. I don't know how to do this particular case, and that's really the only issue, I guess. Well, maybe it's not the only issue, but it's definitely a big issue. Maybe I'm just being dumb. Maybe I didn't need it. Yeah. No, then it's just too high. I don't know how to reconcile this. Okay, so let's say you have, where is it? 313. Right? Also I suck. This is 3 times k. Right? So we just have to make sure that this math works. Is that true? And okay, I mean we're back to the same thing, which is not great, honestly. Now we have 102 and 41, which is actually slightly worse. How does that even happen? We have fewer constraints, so why would that give me? Oh, maybe the 102 is not. No, 102 has to be necessary by default. Right. So if we're doing 87, then 102 has to be one of the number because then that's how you get to 53, right? but then the next time it just goes to 401. No, it could be 226, right? No, well, 226 minus 102 is still too big, but So you have to add the constraint that the minimum of these okay, maybe it's a little bit awkward. Okay, so basically the minimum okay, so you have two ranges, right? The smallest difference is going to be the minimum of the large. Okay, so you have two intervals. They may or may not intersect. If they intersect, then that's fine, right? Then they intersect, then you're fine. If they don't intersect, then the max of the smaller one minus the min of the larger one. So okay, yeah. Okay, maybe. So you have this, right? So then now, maybe this. What the? So we have the max of the smaller element. How does this work? Okay, so for k is equal to okay, this is just weird, but okay. Three, 1, 1, 1, 5, 2, right? So that's for k is equal to 0, I guess. What's going on? Why am I not printing everything? Because it returns early. Okay, fine. If the gap is too big, then it's no good, right? Okay, so if it's 156, I'm looking at the wrong numbers, that's why. Okay, that's good, at least, maybe. Okay, so then here we Did I mess this up? Clearly I did. Otherwise, we just continue, right? It's close enough. Okay. Okay, so we're testing 2.84 with an S with a E. Oh, I'm still looking at the wrong thing, but okay. That means that this means that the next number will go up. You have this, it goes to it's min of the thing, so am I if oh, I see. If this is the case, then there is overlap, is that right? So it's actually S minus E. Okay, that is a I'm just really bad at math, is what it comes down to. It still gives me 87 though. Well, I guess like maybe I'm just writing the same thing in different ways, apparently. 102 and 40 for 1 is are not good numbers, but okay. '87. We have this thing. We're going to try 226 and 140, which I was what am I cannot remember enough. Oh, KSE. So KSE. So then now. $226, 140. $140 minus 53 is 87. Okay. 226 minus 140 is 86. Okay. 87. Okay. I mean, this seems right then. But we have to put 140 into it somehow, because the thing is that it thinks that the first number can be 102. So what I'm just not doing this right. I just don't know the math apparently. Or like, okay, so here we finally do the math right, even though it would mess up other stuff. But it has to be a number between 140 and 226, or one of the numbers is. Basically, I'm saying that this is one of the constraints, but that's not technically true. It is actually saying that one of the numbers is 140 and the other is 226. Maybe. How does this even look? This thinks it is 125. So I mean, this feels like even if we... Oh, no. It feels like they should just give me force on how it gets calculated. Right? Because now it is trying to... These are... How does that not... So that's one thing removed. I guess these things don't matter anymore. The second thing. And then... Oh, wait. This is kind of... No, I mean... But then there's a third thing, right? So how does that even get fixed? Okay, so I guess this gets removed first is why, but okay. Is that what we want though? Why the dupes? I just don't know how to handle the 3 number case, I think. Or the 2 -1 case. Maybe this isn't quite right. Well, one of the numbers could be there, the second one could be there, and then it has to be within thing. And then, yeah. Because then now, okay, let's say we have a sliding window type thing, right? Then now the minimum I see, because then now you have to figure out, okay, I see. I mean, I guess the good thing is that I was not close, but yeah, so then now we have 313, 553, we can construct, was it 313, 87, right? So that means, I guess just 226, 400, and then we have 53, plus and minus, so -34, 140. So we have those two things. All right, so then now, to keep it K, so then K is going to be, has to be between 120 to, so one of the numbers have to be between 120 to 140 plus K. And then the other number is just 226 to 226 minus K, right? Didn't we have that though? I guess they have to be 2 different numbers. I guess that's the problem, is that the way that I'm doing the sweep, it thinks that they could be the same, and that's why my first one didn't work. Maybe. Right? Because then now you have, okay, so it's 140, it's going to be 140 plus K, but it can also maybe be lower, right? It could be, so it, how do I even do that math? I don't know. Maybe I just don't know how to do it. What is this interval that I'm trying to figure out? And maybe this is not quite right. How do I keep making the same mistakes? But okay, fine. I don't know that I know how to do this one, honestly. Maybe I'm just a little bit, maybe it's the mental part. Yeah, that's just not even close. But, and this is directionally right. I just don't think I know how to do the math on this one. Maybe today is just a little bit, not so good on this. And now everything's wrong anyway, but, I mean, at least this is okay. Right. I don't know how to set these constraints in that way. Okay. So here you have two intervals that you care about. I thought that was gross, honestly, but okay, let's think of it another way. What if we have this, and then now we have this, but then we have to make sure that this intersects with a array of I plus 2, right? So that means that it's this intersection with, yeah. So okay, so it intersect plus 2 with, so now we're just 1 point. But also in that case, like I'm trying to create two constraints, but the first constraint or the second constraint depends on the first constraint. I think that's the problem that I have struggled with. And maybe today I just don't have the brain power for it. Yeah, I wish I took a screenshot. Also, I think I messed up in not keeping track of it. Okay, fine. So I don't even know how well I did it, but okay. trying to upsolve this, but I don't. Okay, so let's see. The first question is going to be this. The second one is. Basically, you have this number. I don't get it. I don't know. Maybe I could just do the math. Is that even reasonable? I thought this would work, honestly. But this case is just destroying me. Okay, well now it's just even worse, but why does it think that 81 is good again? Okay, so then let's say you have this. Alright, let's set it. And then okay, well, maybe I just have to do it with this thing. Five. Oh, that's just a little bit okay. Maybe I could do it with part this. I don't know anymore. Yeah, sweep. Okay, I do a sweep. fine, let's just do it. Okay. Oh no, I'll do it. So the first number has to be this, but then the second number could be anything in that range of all the numbers parsing together, right? How do you do a sweep? I guess it's the last number intersected. Okay, fine. So then now, okay, fine. First is S, but then now the last number added, right? Maybe that helps. Let's see. So then you have these two range. Is that good enough for me to solve? Is that even true? First number is between the second is between this, which doesn't even make sense because then now, all right. Yeah, I don't know that. I think at this point I'm just gonna take a peek at some answers. I don't think I know how to do it. I think I just don't know how to do the 3 or the 2 question mark case or whatever. Oh, look, this one has comments. I mean, the idea. So it seems like my idea is right. Or like kind of directionally. Okay, let's see. This is kind of what I was doing. Axis, how does this work? I guess that is how I'm trying to do this too, kind of. That's what I was peeking, but oh, so then you kind of, I see. So then the idea there is that in a greedy way, which is kind of ridiculous, I think, maybe, I don't know, is that you choose the bigger number of the first things. That means that here it would be this number, but then here it's actually, and it's not last, it's the last to be inserted. So this one is okay, if this is true, then yeah, so maybe something like this. I don't know if this really helps, honestly, but okay, so then now we have these things, 35, and then we want 293, right? We generally want them to be whatever, so okay, so if last minus this should be yeah. This is kind of terrible, but okay, fine. I don't know, does this help a little bit with the printing at least? First none. Oh, because one number is good enough. Which is fair. I mean, maybe there's a case where you only need one number. And we have some off by ones, but at least we got the 100 case right. Oh yeah, because the last digit is actually on the removal. On the removal, this should have we kind of lie because we do a +1 on it. Is that all I was missing? I guess we'll see. I spent so long on that. I have a print K here somewhere, okay. Looks okay. Is it right there? I mean, you know, we got closer. My output is 30, but expected 26. So I think it's because of this, because now because I think it has to be that the two adjacent. The reason why I return 30 is because this is no. I mean, this was okay. We should be. Is this so? This is true. Do I mess up something? Why doesn't it go lower than 26? Is this so these are returning true. So what does it return false on? So return false on 29. Why? So on 29 it's 30. But then they're not adjacent, so that's why this doesn't really apply. That doesn't really make sense. Okay, I mean it makes perfect sense, but now I have to figure out how to handle this case. Is it just case analysis? I don't even know anymore. Okay. So this is if there are only two adjacent ones, right? So in this case we go okay, so basically if the overlap, okay, so we have something like this. If the overlap is then we have, I don't know, repeat or something, and if it overlaps, no, if there's no overlap, no, which one is it? If there's no overlap, then you need two numbers. right, back to back, and there's no overlap if max. Okay, so max of the lower one, min of the higher one, max of the low. So okay, so that means that if this is the case, repeat it is equal to true, and then if repeat it and then this thing maybe. Okay, well look, that looks I mean, time to hit another wrong answer. I'm too lazy to take out the output, the print statement. I'm just gonna get a wrong answer. I mean, if I get an unlimited limit exceeded, then that happens, but then that's just a different thing. Why doesn't it give me more? Tell me. Okay, so there's a double thing again, which is probably where I'm messing up. I put 40, expect end is 53. I mean, this part is good, but okay. So it thinks that the numbers are this, but that doesn't even make sense. Okay. Because we have this sequence. I mean, yeah, this thing says 40, but 224 minus 114 is already too bad. These are the intervals that it thinks it needs. Oh, because it thinks that the adjacent intervals. Wait, is that true? No, this is. It thinks that. No. So 106 is fine. 144, is that fine? No, I'm doing it wrong, am I? So it should be 184. I'm taking 144, but the second number should be 184. Because that's the second time that it would intersect, right? Okay, so that means that, okay, so so it gets out, and then 144 gets in. That's what I said my first, but that's not right. So then the last number that is set. So the last number that is set should be here. So the last number that is set should be good here. Okay, I think maybe this is right. Hopefully. Well, I don't know if it's right, but it's righter. All you can do is make it slightly righter. Okay, I'm too lazy to take out the output. I have so many wrong answers anyway. If I get out the put limit exceeded, then I would actually do something about it. All right. Maybe you know, maybe I have some confidence. All right, let's actually take out some print statement. I mean, at this point, I have so many wrong answers. I don't know. And of course, the contest is over anyway. But and it is 2:30 a.m. and my neighbor is slamming the door. Of course. Oh. This one is so hard. Honestly, I'm kind of annoyed at myself because I feel like I had the components. Like I had this for a long time, and I think I just, it's just, I think the hard part is that it's so hard to figure out like what is an edge case and what is not. And I don't know. I mean, I don't even know if it's. I would say it was that hard. It's just that like like for me the hard part was just trying to prove every edge case correct kind of thing. I spent 1 hour. I mean, I don't know. Where did I start in an hour ago? My first wrong answer. I mean, I had like 90% of this actually, right? So like, honestly, I didn't know how to handle the case really precisely, and it turned out that handling the case was just being way by special casing it, which I didn't think that would be enough, honestly. So I don't know. It's very awkward. Yeah, it is very awkward. Like I knew how to do this, but I just didn't know how to prove this to be sufficient. Should I have? I mean, I had like 10 wrong answers, so it's not like I wasn't trying. But anyway, I don't know. This is all I have with this one. How long did it end up taking? An additional hour, maybe? It's not so bad considering. I mean, I tried to take a look at this, and I didn't even really. I don't know. I think I mean, I did take a peek, honestly, but just to see if I was like on the right track. Because like, if I was entirely on, for example, if like the actual solution was like, I don't know, some crazy dynamic programming, then I would just be like, well, well, you know, there's no, you know, I have to throw away and everything, at least like give myself some thing. But it just kind of shows, because I don't think I really I don't think I really like props to Aryan, by the way, for finishing top 10. But I don't think I really like used any of this. Like, I had most of it anyway. I had the binary search. I don't know that I really looked at this. I don't know what it's saying, but yeah, I don't know what this is saying. But other than like, I don't know why there's so many comments though. Very good, well done, whoever this is with comments on this is ChatGPT. But yeah, I think this part was maybe a little bit of a hint. But I didn't do any of these other things, so I don't know. I don't know how. I don't know. I don't. It's one of those things where like it would take me longer to understand them than, you know. But I just kind of, it just pointed to me that I was on mostly the right track, and it still took an hour. So I don't know. But yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, these contests, or everything in between. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye-bye.